So, good morning again, everyone, and thank you for joining us today for this webinar of CLIMAAX Community of Practice on Wildfire Risk Assessment, Learning from Regions. My name is Fulvio Vidal from the Euro-Mediterranean Center on Climate Change, and today I'll be moderating this event. So, before we start, as usual, the few housekeeping rules for today. Note that this meeting is being recorded, so you are free to turn off your camera and please remind to keep your mic off during the presentation. Meanwhile, we encourage you to post your questions and comments throughout the event, while maybe some question come to your mind using the chat you can find at the bottom of the Zoom screen and raise your hand to contribute to the discussion during the dedicated time. So this recording will be available later on, so don't worry if you miss something. And here is the agenda for today. We'll begin with Andrea Truclia from CIMA Research Foundation. He is one of the leading experts, and CIMA is a partner organization in CLIMAAX that has worked behind the development of the workflow for wildfire risk assessment. Andrea will introduce us to the workflow, its rationale, structure, and its use at regional and local level. And following this introduction, we'll have a presentation showcasing the regional experience in using and adapting the workflow, integrating local data and context-specific information for the local assessment. We will hear from the community, intermunicipal community of Beira Baixa in Portugal, and this is represented here by two speakers, João Santos from Green Matrix and João Carvalhinho from the Beira Baixa intermunicipal community. Sorry about this. Um, so then we will have a dedicated time for Q&A and discussion moderated by my CLIMAAX colleagues we have this discussion with our speakers on insights, challenges, lesson learned, and recommendation. And we will collect throughout the event your question and comment to target these during the discussion. We will conclude then the webinar featuring the experience of a sister project from CLIMAAX, Aspect project, because as anticipated in the last webinar, in this new series of events, we will also organize joint events or activities with other European projects and communities in Europe that, similarly to CLIMAAX, are focusing on the development or refinement of climate services. So to create synergies, connection, and foster awareness, collaboration on the advancement of climate information in Europe. So we will have Simonetta Deo, a colleague, who will present the governance case study from this project that is focusing on producing seamless climate prediction for the next 30 years to support adaptation decisions for regional and local administration. And we will close then at around noon with some closing remarks and next appointments in our community. So before dive in, maybe some of you join us today for the first time. So just to remind you that this community of practice represents a space for knowledge exchange and learning between practitioners having a common interest or challenge in climate risk assessment. And we organize events and activities that address the technical and social dimensions of climate risk assessment, trying to respond directly to your inputs and needs. So today we are having the second of a new series of webinars devoted to hazard-specific assessment and the tools developed within CLIMAAX, the so-called workflows, with regions that have been funded and supported by the project presenting their experiences so that we can learn directly from their first-hand experience and engage in conversation with end users that are taking ownership of these results and tools. So after our first event on heat waves, today we will dive deep into wildfire risk assessment. So since we are in a new phase of CLIMAAX Community of Practice, it's useful just to remind that in the past 12 months, we have been doing thematic webinars and workshops on a range of topics related to the climate risk assessment process. I'm not taking much time to remind you all these events, but just to mention that all these sessions are online and you can find them in our website in the community section if you want to catch up and you're looking for key guidance and good practices on these different topics. That being said, now that we are approaching the final year of the project, we are moving into a consolidation phase with the ambition of ensuring the long-term value, uptake, and the impact of the project, and respond to your community requests through these regional showcase webinars and dialogues like the one we are having today, but also a dedicated online community forum. We will share the link into the chat. And finally, with joint events or activities that are fostering exchange, as I said, with European climate service projects and communities in Europe. So without further ado, let's start with our first speaker, Andrea Trucchia. He is a scientist in the Wildfire and Forest Biodiversity Unit at the CIMA Research Foundation in Italy. He is a mathematical engineer with experience in environmental modeling and early warning system, and his main scientific contributions lie in the computational wildfire science, uncertainty quantification, and sensitivity analysis of environmental modeling, as well as the modeling of biofilms and anaerobic digestion processes. In recent years, Andrea research has focused on improving early warning systems for wildfires through spatial hazard and risk mapping using machine learning and artificial intelligence techniques. So his current research aims to identify the main drivers of extreme wildfires in order to provide timely information and optimize fire response resources. So Andrea, thank you for joining us today. I leave the floor to you just to remind you that Andrea has been a key expert behind the development of this workflow. So he will introduce us to the workflow and then we will hear from the region. Thank you.
Okay, I hope that you can hear me just fine.
Good. Yeah.
Okay, yes, yes. Then, first of all, just I ask a disambiguation question about the topic here for the audience, because the wildfire hazard is dealt with in the framework of CLIMAAX project by by the means of at least three different workflow. I've been responsible of the development of the wildfire machine learning based workflow, while other two are available. In the presentation they prepared, all the three of them are described, but if I should retain my focus on the machine learning workflow, we can do it accordingly. I ask our colleagues here at CMCC their opinion on that. I can nevertheless go on the two ways, on a more comprehensive way or on a more focused way, as you wish.
I would suggest if you could do the more comprehensive way, just to have a picture
Okay.
of
Yeah, yeah. Perfect, perfect. Yes. So
We
that
can
was the
see
case.
your slides
Yes.
if you have any.
Yes, I will start now to present. Okay. Okay, so share screen. Desktop number one. Let's see.
Great.
I hope that you are seeing.
Yeah, perfect. Thank you.
Okay, perfect. Thank you very much. So we deal with the wildfire also in CLIMAAX project. Wildfire is a very big challenge because it is a non-linear, multi-physics, and intrinsically random event that can have a different kind of impacts depending on where it happens and what is the coping capacity. So it is a very complex thing, and the climate is one forcing variable to this. And so we need to link the knowledge that we have at our best of our capabilities of the wildfire hazard to the impinging climate change forcing effect. And in some sense, quantifying it is one of the pivotal tools, the pivotal things of our climate risk assessment handbook. At least three methodologies are available in this handbook. The machine learning approach that has been developed mostly by CIMA Foundation, me, of course, and there is also Farzad Kasemi Asma here connected, one of the main scientists behind of this workflow. The fire weather index approach from CMCC, and recently added the response surface model, mostly from ECMWF researchers. Without further ado, let's start with the machine learning approach. This approach, in my opinion, is the most fine scale model in spatial scale. It can go as precise in a space as you put your input layers. So if you have a forest map that it is at about 100 meters, you can have a map of a risk or hazard that is at this resolution. What we lose is maybe the temporal resolution because we rely on averaged to build a model. We deal with the averaged weather models, climate models that are into 20 years averages. And so you can see, snapshots each 20 years. So you don't have much accuracy in time, but you can have a more profound knowledge in space. The rationale is quite straightforward. You take historical wildfire data and historical climate condition and historical land cover condition, and you develop a model. The model learns that some kind of climate condition in this kind of territory with this kind of elevation and so on and so forth is conducive to wildfire activity, training a so-called machine learning classifier that classifies low probability of fire from high fire-prone situation. This is the schema. So we have input variables. It can be the land use, land cover, distance to roads, distance to whatever, a forest type, digital elevation model, climate condition that it is related to the time where we have these observations. And then we learn a model. So the model as inputs mostly land cover, geophysical variable as a digital elevation model and land cover, and climate data. By changing the climate data, you can also see the situation for the future. The workflow uses mostly about the input to generate the hazard, the Eclipse 2 dataset that is like a downscale at 1 kilometer based on neurocortex data, and it can arrive up to 2100, so the next century. Also, as a backup, because some regions were not actually well covered by Eclipse, we added the CHELSA dataset that is quite similar in nature. The result is always similar because you need to select from the 80, 70 different variables, the 7, 8 variables that are more conducive, more correlated to wildfire event, and then you have 8 more predictors that are averaged each 20 years to see different snapshots. And of course, the future snapshots are obeying to different RCP, so the carbon path. Mostly, of course, we focus on 4.5 and 8.5 because they are the more realistic ones, since we are not stopping the emissions. Vegetation can be put as a user-based, but it is imagined to be with the core inland cover that at least differentiate between the conifers and the broadleaves. And then there is the past fires that the standard, it is to use the EFIS database, but in the past years, it do not have fires below 30 hectares. And we know that user can plug in its like cadastry of wildfire. Then, of course, you cannot focus and put yourself at a very local scale because this system works best if you are like at a regional scale or national scale. If you work like at municipal scale and you give in input just 2 or 3 ignition points, not even polygons, the system is not guaranteed to work flawlessly because it is a machine learning approach where the more situation it will ingest, the highest result it can give you. This is a glimpse about the alternative dataset, that is the CELSA dataset. Now you see here, you have everything is downscaled. The resolution is about 1 kilometer. So also we try to be in this dataset, we try to focus a lot on the spatial granularity and at the cost of working in a 20-year period of time. But nonetheless, we can deliver a useful and meaningful result. This is a glimpse with the hazard that you can see at present with different at present and also at future times. You can see that at the end of the story, by combining the susceptibility of fire to the type of land cover, we can see an index of hazard put by the fire. And how we can go from hazard to the risk. From go to the risk, we follow the standard equation that hazard, vulnerability, and exposure. Vulnerability comes from JRC layer like population, ecological, economic, and combined indices. And how we can see exposure. We need to see the physical assets at risk, like roads, buildings, and wildland urban interface. Then typically extracted from OpenStreetMap or similar datasets. And this is a lot of it is left to the ad hoc implementation, local implementation by the user. Then risk, we use at the end of the story, like of course more information is it is not meant to be technical, so much technical, but by combining the indicators with ad hoc matrices, so high vulnerability and high exposure and high hazard means high risk and so on and so forth, we can get up to risk related to this kind of vulnerabilities, so to population, ecological, and economic. And this is and then for vector data such as streets, you can arrive also to have asset-specific impact analysis. So this one, so you can see how this is an example of Catalonia. You can see how the risk regarding road network in Catalonia evolves along the years. So you can see the risk for the road system for 2040, 2060, 2080, and so on. Then there is the other, this was it for the machine learning based approach. So basically now we delve into another kind of workflow that do not implies the construction of a data set and the applying of a machine learning model. This it is the so-called fire weather index approach developed by our friends and colleagues of CMCC. The purpose is to assess wildfire hazard and risk by combining the fire weather index with the vulnerability indicators. Then the risk equation is made of fire danger and vulnerabilities available by JRC datasets. And the fire danger component is FWI, which which comes from from a Copernicus data set that computed the fire weather index from the 70s to the 2098, so nearly the end of this century, derived from climate projections. The resolution is about 10, 15 kilometers because we use this data set. This is a lot of this is not land cover based. This analysis is more weather based, and so it has the resolution that depends a lot on the pixel of the weather of the climate analysis. The climate analysis comes from a data set at 0.11 degrees, so we are forced to be at about 15 kilometer resolution. The analysis in this case is not in chunks of 20 years average, but it is daily and from daily to yearly. So we have so not high precision in space, but a lot of precision in time. The good thing when you work with the daily data is that you can see how long is the fire weather season. So you can say, okay, the number of days with this index, a fire weather index above 30 will be 20. So you have a danger season in summer typically of 20 days. But maybe you can see that this is increasing in the future. So it is a very good insight for first responders. While machine learning approach was a little bit more for planning, for urbanism, land planning. This is more for knowing how hard can hit a single season of fire in the future. We remember that fire weather index is an index used de facto by Canadian and North American response forces to wildfire. Is a worldwide accepted and used indicator. But it is called fire weather index because it does not know if the strong wind or dry air or whatever is above a forest or above a desert, okay? Because it is just weather information. For this, in computing the risk index, this workflow incorporates the percentage of burnable vegetation. Each pixel knows that is a pixel completely urban, so no vegetation on it, or it is a pixel that it is 50% burnable due to its land use. Then, to go more in depth, there is a vulnerability component that uses the population in wildland urban interface, protected area, ecosystem irreplaceability, population density, and the restoration cost of the ecosystem. Those indicators are used in a Pareto system. So you find the points that are the most dangerous, combining all the different type of asset that you can lose, so that are very dangerous on a wall. User can select which indicators to see because you see, I just want to focus on forest and population, or I want to focus also on ecosystem. I want to focus on economy. And then the system automatically sees all the points that make at stake the most of the indicator that you don't want to lose, okay? And here it is an example of the outputs. So with the days with the fire weather index above 30. Typically for Middle Europe, above 30 is a very dangerous day, while in Mediterranean, we tend to stay above 50 or 60 to say that it is a very dangerous day. But of course, everything you can customize everything. And this is one of the results with the areas of highest risk, considering all the different assets, and the lowest risk. And this is the forcing, so this is the FWI. So the darkest area are the area that in the future can express more fire weather. And the dots represent the areas where this fire weather can hit a lot of different assets. Then, of course, there will be, we can go back on this workflow for if you have any question or comments. Then there is the newcomer. I'm very glad to help to have been of help in the revision part of this very interesting last workflow. That is the response surface and methodology developed by ISNWF that still uses the FWI, but it tries in some sense to surpass the limitation of the previous workflow in the sense that you don't need to depend on this Copernicus data set with this resolution and so on and so forth. Long story short, it creates, it bases itself on a data set of a fire weather index, and then it tries to devise a functional relationship between precipitation, temperature, and fire weather. So it tells you basically, I don't know exactly which can be the fire weather in the future because I don't run a new fire weather simulation. But since I do an interpolation with a response surface method, I don't delve into the mathematics of all these that can be confusing, but actually says, let's simplify all things. Give me just the prevision, the forecast for precipitation and temperature. And so I will learn that in this particular NUTS2, so maybe, I don't know, in the Cadiz province of Spain, or in the Catalonia region, NUTS3 or NUTS2, or in Cadiz province, Spain, or the Catalonia region of Spain, and so on and so forth, says, if you give me precipitation and temperature, I can give you an estimate of fire weather index. What is the good thing of this is that basically every climate model has good data, at least good data for temperature and precipitation, because they are the most used variable and the backbone of every climatic analysis. So even if it sacrifices a little bit of accuracy in fire weather index, because we don't use the drought, we don't use the wind, and so on and so forth, we try to get the most. The good thing is that after you construct this, how you can see this orange shade, no? You can see that in the future, if you play with the precipitation and you can see, you can project yourself in the future. Like here, you can see all these black dots are the future condition depending on some model for precipitation and temperature. And then you can see that in the future, you will travel along these orange shades. What is the meaning? Is the meaning that future condition will put you into maybe darker condition for these orange shades. What this means? That playing with precipitation and temperature shift yourself in a realm where FWI is higher. In particular, these
Andrea,
yes.
sorry to interrupt. This is brilliant and very comprehensive. Since I don't know how many slides you have yet.
This is the last one.
Okay, great.
Okay. So basically, with the response survey methodology, we compute the probability of exceedance of a threshold and the average number of days above the same threshold. So analyzing the fire season length. So it's very similar to the previous workflow, but with less input data required. And then if you put to get the risk, here it is a little bit more simplified. You just put the population. So you can have analysis of the future population, and then you can see, okay, how is the probability that this population can experience this weather index? So it is more simplified on this side, but it is more easy to use in the climate part because it just relies on two main inputs. And with this, I concluded the third and for now last wildfire workflow. And I would like to thank all the organizer of the event, and also all the researchers that participated, also from, of course, CIMA, but also CMCC for the Fire Weather Index, and ECNWF for the response surface methodology. Thank you very much.
Thanks to you, Andrea. This is really great, very comprehensive, and much appreciated. I'll now share again my screen because now we will dive deeper into, sorry, into the regional experiences, and I can see that we already have some question in the chat. We will address this later during the Q&A and discussion part. So today we will hear the experience on the wildfire risk assessment from the Beira Baixa intermunicipal community, and here we have two representatives representing different sides and phases of the climate risk assessment. We have João Santos from Grimetrics AI, who is a data scientist, and he works on the CLIMAAX project for three Portuguese regions, including Beira Baixa, and developing data-driven tools to assess and reduce climate risk. Agrimetrics AI applies advanced analytics to integrate satellite data, IoT sensor networks, and AI models to support early flood detection and climate resilience planning for public authorities. We already hear from him in the last webinar, and we know that the company he is working with is a pioneering climate tech startup focused on using intelligent sensing and predictive algorithms to help cities and regions anticipate floods, protect communities, and adapt critical infrastructure. So we also have here João Carvalhinho, who is the first executive secretary of the intermunicipal community of Beira Baixa from 2022. He has a background in agricultural engineering and advanced training in public administration, natural conservation, and natural resource management. Beyond that, he has over 2 decades of experience working at the intersection of territorial planning, environmental governance, and sustainable development, and he served as the head of co-management division of protected areas at Portugal's Institutes for Nature and Forest Conservation. So thanks, João and João, for joining us today. I'll leave the floor to you to explain the different phases and the phases of your climate risk assessment experience with wildfires and your regional background as well. The floor to you.
Thank you, Fulvio. I'm glad to initiate this presentation with João. We, the intermunicipal community of Beira Baixa, participate in this CLIMAAX project with the fundamental technical and scientific support of Grimetrics. We are very happy with this. And we also involve a wide range of local stakeholders to accompany us and participate in this process. We are a public entity with a territorial scope, which pursues the achievement of public purposes with attributions transferred by the state and delegated by the municipalities. In fact, we represent 8 municipalities in the Beira Baixa NUT3 region, halfway between Lisbon and Madrid in the Iberian Peninsula. And these are Castelo Branco, Idanha Nova, Oleiros, Penamacor, Proença Nova, Sertã, Vila Terreiro, and Vila Velha de Ródão, the 8 municipalities. We are a territory with more than 5,000 square kilometers of area and a population approximately with 100,000 inhabitants. So it corresponds to a density of 90 inhabitants per square kilometer. Our region faces critical threats to its development, such as population loss and aging, and of course, high exposure to the problem of climate change. Our participation in this project is thus very important, since we are quite exposed to various risks of natural and origin, which due to the phenomenon of climate change. Our current climate presents very complex situations regarding high temperatures associated with heat waves and rural fires, which occur frequently in our region, as long as long periods with low levels of precipitation, which lead to meteorological drought situations. These node scenarios, the intensification of climate extremes, especially in terms of maximum temperatures, particularly in summer, the alteration of precipitation patterns with potential for reduced water availability or water scarcity, and the worsening of risk conditions for rural fires and droughts that increase their destructive and disruptive potential. These scenarios allow us to conclude that the baseline situation for our region is worsening, especially, as I said, regarding high temperatures, heat waves, and changes in precipitation patterns, situating the potential impact of fires, and droughts, of course. This is why this climate project is extremely important for us. And now I'll leave you with João Santos to explain its application to Beira Baixa. Thank you.
Well, hello, good morning to everyone. I have some material prepared here, hoping you can see it. Are you seeing the presentation?
Yes, perfect. Thank you.
Well, as João was saying, he started with the introduction to the region. I'll be focusing most of my presentation on the technical considerations we took to analyze the region and the wildfires. So I'll give you just a quick context of what João was just saying applied to wildfires. So the variables from the region that actually change and intensify or mitigate some of the wildfire considerations we took. And then I'll talk mostly about the changes we did to the wildfire model. So it's not okay. So right now, just to give you a little context of where Beira Baixa is situated in Portugal, it's on the border to Spain, and it's an entirely interior region, which has a lot of wildfires due to the mountainous terrain, the geographical constraints it has in Portugal. So to give you some of the characteristics of them, some of the main characteristics, it has a lot of forest, so it's highly flammable. The land cover, it's mostly vegetation, and then it has a challenging topography. So it's as there's a lot of elevation changes and a lot of inclines. Wildfires have a tendency to spread really fast in this region. So it's a region mostly focused on quick responses to wildfires and quick responses to fire instances, to help mitigate them as quickly as possible, so it doesn't have enough time to become a big fire, which happened in 2017, for example, or which happened this year, recently this summer, which we had a lot of wildfires in the whole of the interior, the north of the country. It has one of the properties of forests in Portugal is there's a lot of land abandonment, and there's a lot of distributed ownership of the land. So most of the forests in Portugal are privately owned, and there's a lot of fragmented land ownership from this. So it's not easy to maintain the land, and then it's not easy to actually make the owners take ownership of maintaining the land. Besides this, it has the whole of the usual problems with with less populated Portuguese areas, which is an aging population, very dispersed. There's a lot of small villages and a lot of small towns dispersed around the whole of the region. So the vulnerability, the population vulnerability is somewhat hard to define, as there's a lot of settlements, small settlements with not too many people, but with people living there, and this complicates most of the wildfire responses, as what happened in 2017 in Pedrógão Grande. And we see this every year with how the civil protection deals with population. And then there's the usual infrastructure exposure, so road networks, health services, the usual of maintaining society. There's a lot of it spread around the whole of the region. So these are the 5 main considerations we took when analyzing the region and when taking the decisions about what to include, what to reduce, and how to modify what the CLIMAAX framework serves as an entry point to the wildfires, the wildfire analytics. And then we built on that, taking into account these characteristics. So just quick introduction again. Beira Baixa is affected by wildfires yearly. It's one of the most affected regions in Portugal. It serves as a main response entry point for the civil protection and for firemen during the summer. So there's a lot of mobilized firemen in Castelo Branco and in Beira Baixa during the summer to help fight the wildfires in the interior region, the mostly affected region. And there was a lot of big wildfires happening there in the last few years. The example that everyone knows, which was international news, which is Dragão Grande in 2017, and then recently we also had the year with the most the recent year with the most burnt area, and Beira Baixa was also severely affected by this. So starting with the modifications we did to what Andrea was presenting before, the wildfire model. So the way we do predictions, we changed a lot of we changed some things. We maintained the base idea, but we changed how we look at temporal evolution, which was one of the main problems we had in the first phase. Was the wildfire predictions weren't evolving with time, so it was mostly focusing on geographic constraints, and it was very geographically rich, but it wasn't climate. It didn't take into account the climatic variables. So we took a lot of steps to actually combat this and to actually have something that would make sense, that we could validate with other sources of information, but which would not only take into account climate, but also the geographical constraints and the geographical variables. So what we did was we changed the climatic variables to just 3. So we maintained it as simple as possible, and then we forced the model to actually look into the trends that happened with these variables. So along the 5 periods. So we maintained it to the summer heat moisture index. We maintained this into the summer only because if we did the annual, it wouldn't evolve over time, because the moisture is very spread along the year, and we need to look at the extremes to see how it evolves. So to see how climate change affects moisture. And the heat moisture index it's an index comprised of various things, also including temperature. And we look then at the mean annual precipitation. How precipitation will evolve over time, and the mean annual temperature, which is how temperature evolves over time. As André said, the backbone of most climate projections are these 2 variables, and we analyze them at the 2 levels. One of the main things we did was we didn't focus the climate model into only the region. We decided, being that Portugal has Portugal being a small country and having a lot of different wildfire distributions along the whole of along the national level, we decided to do the modeling, and we do the training on a national level to keep as much information as possible and to actually look into the geographic constraints. For example, in analyzing another region, for example, Baixo Alentejo, the mostly green area there, which has some hotspots, some wildfire hotspots, we weren't able to actually take any conclusions using a regional model, but the national model actually lets us take conclusions and lets us actually analyze how things work, because it has the whole information for the whole of Portugal. This is only made possible because at the national level, here in Portugal, wildfires are one of the main issues we face yearly. And so we have a lot of information regarding wildfires. We have we have a very comprehensive catalog of every burnt area and every wildfire that happens year upon year, which is maintained by one of our national organizations. And then we also have a lot of studying and a lot of predicting of how wildfires will evolve in the short term. So there's a lot of this investigation in the short term, and we can use that investigation and those methods they use to validate how we do our own. So there was a lot of iterating over this model, but the main hotspots and the way the model is currently looking at the main fire probabilities and the main wildfire hotspots, it's currently validated and it follows what is widely accepted even in Portugal at the national level. So taking on that model we developed and then actually looking at the regional level, we were able to actually to see how it evolves over time. So the model started taking into account actual climatic trends and not just the geographical constraints. And we can see this at the different scenarios at the different time periods, how wildfire evolves for the region. So in the Beira Baixa region, we have those main hotspots in the north, which are it doesn't have a lot of historical wildfires, but it's a region with a lot of potential to burn, with a lot of potential so it's wildly controlled in the north of the region, the northeast of the region. And then we have that main hotspot in the west of the region, which is Serra da Malcata. No, it's not Serra da Malcata. It's around Pedrógão Grande, which was where the main fires happen year upon year in the north and there. And so we can see that these are regions which already have a lot of wildfire risk, but it's evolving and it's expanding. So we can actually analyze new dangers and new regional dangers at the very fine-grained level, which we can use to take into account other things. So this is the hazard we took into account for other analytics later. This is currently the ground truth of the model, which we are taking account to do the modeling for other things. And then when we went into the risk, when we analyzed the risk, we decided to for now not focus entirely on vulnerability. So we have the overlaying of the vulnerability, but we're focusing mainly on hazard and how we can combat this hazard. So how we can actually fight wildfires and analyze the response capabilities for this. So we decided to do a bit of a weird matrix, a frontline matrix, because we are taking into account response metrics, and because we are taking into account response metrics, if there's no fires, we shouldn't take into account any risk. So we front loaded it mostly to this matrix. We're using this metric as the truth for the response analytics, and we can focus on this for the next ones. So the first analytics we did, it's for water availability. So we divided this into two things, but we focused on where are the water spots, where can we go grab water to fight fires, to fight wildfires in the region, and if there's any need to actually expand on this and to build new water points, new spots where we can grab water to combat to fight fires. And we did this for two types of firefighting vehicles. So we did this for aircraft and for aerial firefighting, and then we did this for terrestrial firefighting with fire trucks and with firemen actually combating the fire on the ground level. So the first one I'm going to present is the aerial firefighting, what water points can be used by aircraft, and how far are the power points present, are the water points present in the region, how far are they from the actual hotspots, from the actual dangerous zones. So we did this very parameterized. Yeah, we did this. We changed a lot of variables, and we defined the variables to be easily changeable for this analytics. Just because we, as at Read Metrics, don't know the real distances and round trip times necessary to combat fires. So we did this very easily editable to actually change this when talking to stakeholders, and when the stakeholders present a little problem with the distances there, we can change them. But we then produced these maps, these cartography, which showcases where the water points are in the region. So we did this in two different methodologies because of different considerations we needed to take. So we did this one focused on water point density, which limits the maximum volume of a water point to something. So, for example, rivers wouldn't count as this huge water point that actually fed the whole of the region. So we could focus mostly on how dense are the water points and how quickly they are, because having a 10,000 square meter water point close by could be better than considering that the river, which is 5 kilometers away, for firefighting reasons. So we did these two methodologies. We present them both to stakeholders. The stakeholders found value in both of them. So we are keeping both of them in the consideration in analytics. The second one is mostly focused on volume. So if you have a giant water point that feeds the whole of the region, that has millions and millions of liters of water, that water point is seen as a dark blue spot, and it's used for firefighting, and it's considering that it feeds the whole of the region. As we can see, Berovaisha, there's not a lot of density in water points, but there's a lot of water in each of them. So we have all the rivers. There's two main rivers that cross the whole of the region, being Tejo and being one that was Northworth. I don't remember the name. But so not much in density. We have some hotspots in density, but then in volume, there's the map is very different, and we can consider this very differently. So for both of these methods, we did using that matrix, we did a quick classification of risk, a quick classification of how a quick overlay of how a water availability interacts with new wildfire danger. And as we can see, and as I was introducing earlier, here in Portugal, one of the main risks being wildfire, the wildfire responses are very optimized. So we can see that while the hazard map is mostly red, and it's mostly very dangerous, and it showcases a region very propitious to wildfires. Here we can see that the responses in terms of water availability kind of mitigate this somewhat. But there's a lot of new red zones, so a lot of zones which aren't mitigated as well as they could be. And so we get this map to analyze that at a more regional level, and we can actually zoom in and see which zones and how we can fight this in the future. There's a lot. One of the things we didn't consider and could be somewhat of a flaw in this methodology is topography. Elevation complicates a lot of aerial firefighting. So this wasn't taken into account because it's very difficult to do 3D distances and 3D ways of analyzing how the topography interacts with aerial aircraft. So currently, this is considering the whole region as flat, which is a bit of a flaw in the map, but it still gives us a general idea of how the water points are dispersed and how this can be used by response units to actually fight wildfires.
João, sorry to interrupt again. I know that you have a very comprehensive approach, which is brilliant. So if you could please speed up the presentation, and since we are running out of time.
Yeah, okay, I'll go a bit faster. So this is the second methodology, focused on volume, not density, and we can go forward to the other things. For ground-based firefighting, the idea was very similar, but it's mostly focused on how much does infrastructure actually allow the firefighters to use water to combat the firefighting. So we did this using a routing machine. So we actually did a map in a 1 kilometer by 1 kilometer cell grid to actually analyze what was the distance using infrastructure, using roads to reach the nearest water point and actually combat the fire. And we did this for the whole of the Beira Baixa region, and then we crossed this map with the hazard map I showcased earlier. So we got this general water availability map for ground-based firefighting. So this is maintaining the road necessity, and it has no considerations in water volume, considering fire trucks they use a lot of water, but most of the water points can actually feed them very well, and they have no issues with this. So we got this map of how far water points are for the whole region, and then we crossed this map with the hazard map, and as you can see, the same hotspots are showcasing in the north and in the west of the region, and so we can analyze this at the more regional level. Where can we add on the water availability in the region? So afterwards, we applied the exact same algorithm, the exact same methodology to analyze fire stations and to analyze what we call LEEs, which are parking spots, which are places where firefighters are parked and can be and where response units can be parked in the more dangerous seasons. And then using the same routing machine, the same service, we did the same map. The distances were a bit different to actually analyze how the response units can be spread across the region, and how quick they are to respond to in the fire anywhere. And as you can see, most of the, excluding the northeast region, which is mostly a natural park, the main hotspot of wildfires is actually very well covered by response units because of the necessity from year upon year to actually have firefighters in the field to fight wildfires, which happen every time. Afterwards, we took the infrastructure, we used regional data sets to actually grab the infrastructure, and then we crossed the infrastructure exposure where they are with the dangers of wildfires, the predicted dangers of wildfire, predicted hazard. The maps aren't very comprehensive. This will also be available in geographical formats to be analyzed in GIS. But we got the maps. These ones are for healthcare units, so pharmacies, clinics, hospitals, and local health units. And this is the spread across the whole of the region. We have some of them which are red and some of them which are actually in exposure of danger. But being as they are mostly in urban areas, the model doesn't actually take into account a lot of the danger, only in some regions, in some of the towns and villages across the region. Afterwards, we did the analysis for roads. Which roads are affected, which roads are in the danger of closing, and because of wildfire, which roads can be which could be need to be maintained because of wildfires, etc. We did this for main roads, secondary roads, and then the what we call the forestry roads, the beaten paths. So we analyzed all of it from public sources, from publicly source information, and then we analyzed which regions are in danger. As you can see, the northeast doesn't have many roads, so it's mostly natural parks. The most of the vulnerability here in Penamacor is ecological. But the whole of the region, the main hotspot for wildfires is populated, and there's a lot of people there, and not a lot of people, but there's people there, and it's mostly in danger, and there's a lot of exposed infrastructure. We also did this for elderly care homes, so which a lot of villages and a lot of small towns do have these, and there's a lot of exposed danger for elderly care homes. So we analyzed this, and we actually found a lot of them which are in a somewhat high fire hazard category and across the whole of the region. And then just to give you some of the data sources, this isn't very extensive. We have a lot of data which isn't explicit here, which will be in the report and publicly available then. But what we were using, the land use we used for the model is the national one. We exchanged from the core into the national one, which is Carta de Ocupação de Solo 2023, which is maintained by our government. And it has its issues, but it's much more fine-grained and much more real and actually important to relevant. It's much more relevant to the classes. The classes are much more relevant to our national reality than Corinne is. Corinne has a lot of classes which are only present in the north of the northern Europe, and a lot of things we don't actually see. So this one, besides having more classes and having more fine-grained resolution as it's vectorial, it's also much more easy to work with in our case, where we actually know what are the dangers and what land uses are dangerous for fires. Then the topography, we use the local digital elevation model from the University of Porto. And then the exposition data, the fire stations, the water points, everything we actually analyzed and crossed with the hazard comes from regional data sets or national data sets, which were intertwined and analyzed at the regional level as well. And with this was the work done at the technical level for the Beira Baixa region.
Thanks a lot, Joao. This is really great. I think that the approach is comprehensive and really valuable for the region. I mean, assessing the different assets and infrastructure that are exposed. So we have a few questions in the chat. Maybe some of these questions have been already addressed. So we have Athanasios. Maybe you want to take it up yourself or react to what Joao just presented. But he asked for the machine learning workflow, if you could explain, and this is maybe directed also to Andrea, how and what can we change in the original Catalonia dataset to create a regional base one for our cases? What can we do when regional data are scarces? And how can we adapt local variables to the workflow? So this, to some extent, has been already addressed by Joao's presentation, maybe, but if you want to complement, here is the chance.
Maybe I can add some words on that. Then, of course, Joao can complement based on its hands-on experience on the overall process. But like the good part, let's say, but also the most difficult part, it is 50-50 as always in the workflow, is that you have all the pieces, blocks of the analysis, and each block can be a standard block put by EFIS dataset or Corinne dataset, whatever, OpenStreetMap, and so on and so forth, or your personal cadastry or regional cadastry. Like, let's go in order. Wildfire repository. Wildfire repository, if you are a municipality, sometimes, in my experience, you have a very particular point-to-point ignition map that seems good, but in reality, if you do this analysis, a very small scale, you don't really learn the driver of wildfire. You just really learn that arsonists stay in this part of the country. You know, like it's better to do as Joe did. So it just as the cost of maybe 10 minutes more of computation or half hour more of computation, you do it at least at a regional level, like NATS 2 level, or at a national level. And then you cut, because you need to be ubiquitous and learn how much fire situation is possible. Then virtuous countries like Portugal have their own dataset of wildfire. It is not so common maybe in northern countries, but EFIS now is very good in the latest time that it has also little fire. When incorporated to Sentinel-2 dataset is better. Land use is very, very important, but of course, if you want to do analysis at a big level, you cannot use the land use with the 20 classes of your municipality. You need to choose a balance between having important data, but just on a place. It's better maybe to find a balance and have a dataset that encompasses at least ANNATS 2 or above. Then the exposed features, then it is the place where you can play the most because the hazard is related to physics, to weather, to land cover, of course. And so you need to be rigorous. You need to use, the national data set of forest type and so on. But your municipality is your concern. If you see that you have a huge population of elderly people, you do the analysis on shelter, like the retirement houses for elderly people, the clinics, and so on. If your municipality is a very big logistic hub with a motorway full of, tanks, like machine, like vehicles that with oil tanks and so on and so forth, well, the road network need to be analyzed. Like when you cross the hazard that for us is from 1 to 6, so it is classed hazard, you can put what your vulnerability to have a risk level. And if you can play a little bit with the tables and in Python are very easy to use, you can plug in whatever vulnerability you want to do an ad hoc study because the most complex thing is having the hazard layers. To get the risk, we provide an example with just the 4 risks of JRC, economical, ecological, social, and so on. But it is really the place where municipality attitude can make the difference, in my opinion. And then, of course, I leave the word to Joao if any more words are needed. Thank you very much.
No, I'll make my words your own because it's what I've experienced. What I've experienced in the last few months was exactly this. It's the methodology is very adaptable to the data sets we have and the data sets that regions have. And luckily in Portugal we had a lot of stakeholders which pointed us in the right direction to where to grab the things we needed. So it wasn't really that difficult in our case, but it's really, really adaptable.
Thank you very much, both Andrea and Joao. I think we have more, not technical question, but more about your content. So I really appreciate also your mentioning about the stakeholders because this is really important. We have a few minutes more, so there are a few questions for you. So if the workflows from Joao are available, actually not workflows, but maybe you can publish something or I don't know, make them available. How can people use the type of method and approach you used?
Okay, so currently the plan is to follow what we did for phase 1, which is there's another repository and we're going to include code. We're going to include the notebooks we used, but this will be done for this deliverable. So for the phase 2 of CLIMAAX, we're going to do this and it's going to be available for the CLIMAAX community of practice as it was for the first phase. So we're open. It's supposed to be open code, so we're open for anyone to use it and for anyone to modify it as they see as they need as they want.
Great, thank you. We have time for maybe another very quick question if anything emerge in the chat or someone wants to introduce a comment or question. Otherwise, we will go through the next phase of this webinar. I'm really curious to hear more about the overall engagement approach and how this informed your risk assessment, but I'm leaving the floor to the audience. Otherwise, I can ask you just a quick comment about this. Maybe Joao Carvalhinho could take the floor and very, very briefly, which stakeholders and when?
Yes, just very briefly. I think it's and João, the work we have been doing. It's with you with very strong and permanent involvement of local stakeholders. That is, it's been very important for refining the methodology, the model. The stakeholders from public administration that lead with the rural fires in daily basis, but also local private interests of the forest sector and the social sector too, because the rural fires do involve persons in the territory. So I think it's very important that the 2 dozens or more of local stakeholders that are participating with us in this process. This participation is very important.
Thank you very much, Joao, and thank you to all our speakers again for your contribution to the community of practice. It's really great to see how the workflow has been used, adapted, and let's say integrated with more information about exposure, vulnerability, and capacities, and so on. So now we have, unfortunately, to move on to the next phase of this webinar. So thanks again, everyone. And let me so we will have a colleague here from CMCC that is going to present the Aspect governance case study. Simone Taddeo here. Aspect basically, as I said, is a Horizon Europe Presidential Innovation Action project that develops and improves seamless climate predictions for the next 30 years to support adaptation decision across multiple sectors and aims to deliver co-developing with stakeholders, but useful and usable climate predictions that span different timescales, spatial levels, and governance contexts. So today, Simone will present the case study focused on the governance sectors, on producing climate information for regional and local administration. So Simone, the floor is yours. Just to remind, Simone is a colleague that is an environmental economist and green finance analyst at the Euro-Mediterranean Center on Climate Change and the University of Venice. Simone,
Thank you
up to you.
thank you very much, Fulvio. I will share my screen. I prepare like some slides here. You can see my screen. Okay.
Yeah.
Perfect. So thank you very much, Fulvio, for the introduction. I will talk today like about the Aspect project, which is like a cross-cutting European project that we have like at CMCC that Fulvio has earlier said develops advanced climate services to support services in terms of like adaptation planning. So its goal it's mainly to provide reliable climate information, risk assessments, and decision support tools that help policymakers, especially local and regional authorities, and governance users to understand future climate impacts and design effective adaptation strategies. I will go quickly on the Aspect objectives. Basically, we aim to reach some kind of goals. Most of are like in terms of like improve seasonal to decadal forecasts. To develop like extended initialized forecast up like to 30 years, combine forecast across like different time scales, and as well like produce like high resolution information on extremes. In this CLIMAAX community of practices, also like we want to launch a kind of like a survey prototype that we are building through our super users. So basically just to give like a bit of a background of CMCC governance case studies. We now like working with Emilia-Romagna regions. For those who don't know, like Emilia-Romagna regions is like one of the most like advanced region in Italy and like in Europe, like for climate-related innovations. So we now like are working with like a kind of like institution, like a practitioner that we are like in this kind of aspect project, which is the ARPA Emilia-Romagna. Basically, like the Emilia-Romagna region has identified like two priority climate changes, like extreme heat and severe like rainfall events, and together with super users that, as I always said before, it's like ARPA Emilia-Romagna. So what is like basically like a super user like in a nutshell? It is like a practitioner, like a testing early that tests like early our like prototypes and tools that provide in technical feedback that helps like translate scientific outputs into the operational needs and represent like in a way like the perspective of highly capable end users. So why we choose like ARPA? Mainly because like this is like one of the most advanced research driven public agency with strong modeling and climate expertise, and it also like provide like a high level guidance on how like climate information should support policy prospect. So together with the ARPA Emilia-Romagna, we are developing our kind of like prototype that helps like to support adaptations tools for the local and regional authorities. We identify basically three components on the governance case studies that are like fundamental to support evidence-based adaptation planning and to design effective forward-looking policy tools for territorial resilience. So one part is related with high resolution convective permitting climate modeling, which is led by two institutions, SMCI and University of Zagreb, which allows us to capture like local extreme like events, like for example intense rainfall or heat waves that traditional models cannot represent. Then we have like the downscaling of like a statistical prediction to regional planning scales that translate complex climate information into forms that local authorities can actually use for the design, for infrastructure planning, and for zoning mainly. And then we have like the application of climate projections, like in hydraulical models, which is led by CMCC Venice, that shows like how future like climate condition will affect rivers, floods, droughts, and water so together, taking all together, these three dimensions provide like a comprehensive like climate risk evidence base that governance actors need to understand for identify like evolving climate threats with a higher precision, and like that help in turn prioritize like adaptation investments and redesign, let's say, planning tools and regulatory instruments. So why I'm here, basically, why we cross like the aspect governance survey in the CLIMAAX community of practices. First, because like the community of practices of CLIMAAX is really an important pool that collect local and regional authorities that are really important for us in our survey because we want to a way like obtain like a kind of like replicability like across regions. So what I mean, so assess whether this kind of prototype structure can be applied to governance bodies with very different levels of technical capacity, since like we are dealing with ARPA Emilia Romagna, other local and regional authorities maybe may not like have like the same level of expertise. So we want to test the maturity and the access to climate information. Then we want to test like the flexibility of formats. So test if like this kind of survey, which incorporates our components, accommodates both highly technical users as like ARPA and low capacity authorities, for example, like small municipalities, without like losing like relevance or clarity. And then there are like some other objective that we aim like to achieve through like this kind of surveys that are transferability of insights, so evaluate whether the information collected can support the development and governance, and also the adaptability to like to diverse governance system, which determine if like the survey can be customized for different administration structure. This is we thought that was really integrated with workflows, because like which help understand like whether this kind of governance survey can evolve into let's say like a standardized component of the CLIMAAX processes. So ensuring also like supporting long-term capacity building across like the entire community of practices. So this is like the link of the survey, which will take almost 10 to 5 minutes. I don't know if you can see my screen. This is like the link that will be like, as I said before, like useful for local and regional authorities that can help us like in turn to scale up like this kind of prototype that we are finalizing in the governance case study within Aspect. Just like a brief like overview, we are not going through the entire survey, but this is like how like it will be appear, and we ask you like to submit your answers, since like it will be really useful your feedback for like future direction of our. So basically here, as you can see, we can start with like initial question that's help us like to identify which kind of like level or which are like the climate threats that affect your local administration. And then there are like some questions related to the user to the end user governance local authority. That, for example, here you can really easy answer to all the questions related to your position, and this will help us like to identify which are like the main target of this survey. I'm just like picking like the like a random question. So the first part will be like more about like your professional background, and now we are going to like to have a of question about our prototype. So this then like we'll continue with our prototype that will be like displaying all the all the components that we already described with graphs, with some like a really easy question that will help us like to identify which are like the main challenges for local and regional authorities in our like case studies. So I think like I took like the right timing. I don't know if you have like any additional curiosities about like this survey, but like I want to really underline and highlight that this kind of surveys is really important for our projects to like better frame like the needs of the local and regional authorities. So if you can take 10 minutes, 15 minutes for us will be really highly appreciated. Will let us like to continue with our work that we are doing in Aspect. I think I did like in time.
Yeah, thank you very much, Simone. I think this is really appreciated, and also to remind that this community of practice is, in fact, a space not only to, let's say, deliver useful content for end users, but also for co-designing resources. And this is also the chance to do so also with Aspect project. I can see that there are a few questions in the chat about the availability or open access of the deliverables. So we know that in some cases the regions are not allowed to share data sets due to licensing restrictions and so on. So we will check with the region what we can do and what can be make open access. And we will follow up through an email as usual. So since we are running out of time, sorry for that, but we need to wrap up today's session. I want to extend, first of all, a big thank to our speakers and you all for this insightful discussion. And before we close, just an update about the upcoming event that is in February. So we will gather again next year in February 19th for a new webinar on the workflow dedicated to river floods. And so we don't have a link yet to share, but please mark your calendar and we will follow up in the upcoming days about this new webinar. And as usual, to conclude this session, how to continue remaining engaged in the community of practice, you can join our LinkedIn group, but also the community forum that has been recently launched and that we aim to populate more and more with materials like those you asked about the deliverables, but also the experiences from the regions and so on. So please keep it up with these resources, and also you can take our surveys, but also subscribe to the community of practice to receive communication of further updates. We will send an email to you that register to the events, but to remain updated with the community, please go in our website in the community section. You will find a button where to insert your email, and we will keep you updated on the new events and updates from CLIMAAX in the future. So that being said, we saved a few minutes at least, and I want to thank you again for joining us today, and we look forward to reconnecting in the new year. So wishing you a restful end of 2025 and an excellent start for 2026. Thank you and see you next time.